Hello everyone, it's Kevin L. Jackson. I'm here in San Francisco at the Upgrade Reality Conference with NTT. And I've had an opportunity to meet with Dr. Yoshihisa Yamamoto.
Yes.
Oh, thank you very much for taking the time
Thank you.
to come see us. You are the director of the PHI. So what are you doing? What does PHI stand for, and what do you do there?
We are studying the future architecture and the principle of our computing system.
So it sounds like you're doing a lot of work in advanced computing, but in the news, the only thing you ever hear about is quantum computing. Is this really quantum computing, or is it something else?
The current mainstream quantum computing
Right.
is based on particle. Our approach is actually different. It is based on the field rather than particles. So our photon is delocalized and coherently spread in the entire computing machine. And in those settings, the field-based computing system, even single photon can simultaneously exist many memory sites as its partial waves. And those partial waves actually are still perform nonlinear sort of signal processing and execute the trustable computation.
Sounds like you are really leveraging NTT's history in photonics.
We are really trying to sort of merge the NTT's photonics technology and the Stanford nonlinear optics, I think, our experience to realize this type of new computing system.
It sounds like you're really in a completely different area with respect to quantum and traditional computing. What has surprised you in the work that you've done?
We are rather confident by our theoretical consideration and the numerical experiment that if the computing machine has one and only one photon, as I said, the partial waves of this single photon are actually store many bits of information and perform nonlinear information processing and output the trustable computational result. So this is actually, I think, rather remarkable difference from the particle-based quantum computing approach.
So it sounds like just with a single photon, it could be in multiple storage locations?
Yes.
Is that true?
That's the point. The single photon can exist in optical pulses simultaneously as a linear superposition state. And those sort of extremely weak field still carries the so-called spin up or spin down information for computational purpose.
Well, during this week, during the Upgrade Reality Conference, NTT has made a lot of major announcements about ION. And one of the components of ION they have talked a lot about is disaggregated computing. So does this approach support disaggregated computing?
Yeah, our approach is probably, I think, at this time alternative to again mainstream silicon photonics-based optical computing system. Our material system is different from standard silicon or 3-5 compound semiconductors. It is a lithium niobate nonlinear optical material. But we believe that this nonlinear material, particularly thin film lithium niobate platform, is a major sort of game changer for optical computing future.
Well, one of the optical computer components that ION leverages is the photonic transistor. Does your work, is it part of that?
Yeah, the equivalent key device in our case is optical parametric oscillator. It was actually invented the 1965, I think, many years ago, both at Bell Lab and also at Stanford. At the time, the size of the oscillator is about a meter.
Okay.
And now our current thin film ratio niobate optical parametric oscillator is actually a few micron ring cavity on chip. And so and also our threshold pump power was reduced by many orders of magnitude compared to our existing optical parametric oscillator. So that sort of on-chip optical parametric oscillator is a key element, somewhat equivalent to our transistor in current digital electronics.
How soon will we be able to see the results of your work in everyday life? I mean, the whole conference here is about upgrading reality. When will this work upgrade my reality?
Well, that's hard to tell. We have a sort of a step-by-step approach. Yeah. I think this thin film lithium niobate platform can be already implemented in the existing telecommunication technology as transceiver modulators, and also our nonlinear wavelengths converter in laser industry already. But if we talk about sort of replacing the current GPU and FPGA as an accelerator for in the data center, I think it takes a while. I think we need to actually develop the whole system on chip rather than individual component. Yes. Right. So it takes a while.
It'll take a while, but my reality will be upgraded.
Yeah, hopefully.
Well, thank you very much, Dr. Yamamoto, for spending the time
thank you.
With us.